So we'll be writing our first C++ program. But before we go ahead and write our first C++ code, let's understand some fundamentals again. So we'll be writing our program in a program file. So let's assume we have a program file and the program is responsible to, let's say, display a hello world message on the screen. So we'll be writing all that logic in this program file. And the program file will be identified by a name. And let's assume that our program file has a name example and it has an extension .cpp. So whenever you are writing a C++ program, you'll be giving cpp as a file extension. Well, this is a text file, it won't run whatever logic you write. You need to translate that file so that it is understandable by a machine. So what we need to do is we need to submit this program to a tool that will help us to translate the code in a machine understandable format. So we'll give our program to a compiler. A compiler will be a tool which does the job of translation, but it is not just doing the translation, it basically performs two things. So the compiler performs something called as analysis and synthesis. So analysis basically means that the compiler is responsible to check whether your program written, is it lexically valid, is it syntactically valid, and is it semantically valid. Okay, what does that mean is that the lexical check basically sees whether the function names or the variable names, whatever you have given in the code, are the following the language rules. Next thing is syntax is more of the grammar. The language defined has its own grammar, so we are supposed to follow that grammar for writing statements, different types of statements we write. And semantic check basically is going to check whether the statements that you have written, is it making sense. That's what the compiler does before it generates the machine code. Now, once the compiler gets any error, if your code is lexically, syntactically, or semantically invalid, in that case, compiler is not going to translate and generate any machine code, rather it is going to throw an error, and we'll call that error as a compile time error. Next, after, if the analysis is done and there are no errors in the code, then it is going to perform synthesis, and what it does basically is going to do some code optimization, and it's going to generate a target code. Now this target code will be generated in a separate file, and let's call that file as an object file. So it's called as an object file, and that object file again has a name. So I'll give some name to the object file, and the name of the object file will be same as your program file name, but will have an .obj as an extension. So I can say this is a source file and this is an object file. Now the object file is generated by a compiler, and what happens is that again this object file is not an executable file, and this object file again has to be submitted to a separate tool that will generate the that will generate the executable code, and the program is called as a linker. So linker basically is going to take object file as an input. It can take one or more than one object file as an input, and it can generate the binary code. And in our case, what will happen is that the program that we'll be writing, okay, uh, example.cpp program, once given to a compiler, assuming that if everything is correct with the code, it's going to generate an object code, and then we'll be submitting that object code to a linker, and that will generate an executable code, or we can call it as a binary file. And again that binary file will have a name, so let's call it as example.exe. So this is a very basic compilation and linking model of a C++ program. So before we go ahead and write the program, so we need to understand this is what is going to happen, that we'll be writing our program in a file. The file will have a name and an extension. the program file will be given as an input to a tool called as a compiler that will perform analysis and synthesis. And if your code is lexically, syntactically, and semantically correct, I'll be elaborating more on these concepts as I'm going to write the code. And if everything is okay with your file, then it's going to generate an object file. And that object file again has to be submitted to a linker. So linker is basically responsible to generate an binary file. The name linker basically says that it is supposed to link things. It is, if you see more technically, linker is going to link your function call to function definitions, and it's going to generate the binary file, and that binary file will be an executable file that you can run and get the output of the program. So we'll write the code and I'll explain you gradually. So I will be using Visual Studio command prompt to write our first program. So I'll first locate where I have the entry. So I have installed Microsoft Visual Studio 12. You can also install the latest version. And I have a developer command prompt. I'll just click this one and it should open the command prompt for me. So I can open again. And what this does basically is it is just setting all the required environment variables for me. And I'll just increase the font a bit so that it is visible. And now I'll create a folder in a drive called as learn CPP, C++, and I'll go to that folder. And what we'll do is we'll create our first file called as example.cpp. So I'll say notepad example.cpp, and it should open a notepad. And what we'll do is we'll write our first C++ code here. So I'll say int main return 0, and we want our program to display hello world. So this is the message we want our program to display. And how it is going to display is C++ says that there is a cout. It's basically an object. So I'll say, well, C++ says that cout is an object. If you are familiar with C programming, you'll come across printf function. But in C++, we don't use function to display something. Here we have a cout object, and just it's an object, and this object basically is going to help us to display a message on the screen. Gradually we'll understand what are objects and how they work, but let's understand how you can just structure the first program with some very commonly used objects. And moving ahead, I'll be explaining you more on the same lines. So what we need to do is we need to include a header file. So IOStream is a header file here. We don't have to write .h, okay? And we need to write one more statement as using namespace std. Okay, so we have written hash include IOStream. We have written using namespace std, and this is an entry point function. So what does that mean is that our program execution will start from main. So this is our main function definition, and this is our entry point function. The program execution is going to start from main. Cout, basically this line, this is the message that will be displayed, okay, on the screen. And cout is an object that will be responsible for displaying the message. I'll say okay, it's an object that will display message on screen, okay. And every program should be terminated by semicolon. So I have forgot semicolon to write. I should write a semicolon in the end. And if I want to know, okay, from where the object is coming. So as of now, you can understand that, okay, the object is coming from a header file IOStream. So there is a header file IOStream, and from that file, the cout object is coming. Okay. So I'll be explaining you, like, what are different header files and what is the purpose of different header files. There are a lot of things around here, but you can just go with the sample code as of now, as we gradually understand the concept of classes and objects and so on. So I'll just ensure that my code is correct. So I've got the code in place, and what I'll do is I'll save my code. So I'll close it. So as of now, what I can see is that if I just put start dot, I can see there is only one file, example.cpp, in this folder. And as I had just explained you that, you write a program file in example.cpp, and then you can submit your program to a compiler. That's what we'll try to do. So we'll submit our program to a compiler. So we have a compiler, CL is a compiler. So if I just type CL, enter, so it says it's a Microsoft C++ compiler we'll be using. And I'll just say CL/C, and I'll give the file name example.cpp. And what it should do is it should take this file as an input and it should compile. So let's press enter and see what happens. So okay, let me check. So it has given me some warning. We can ignore that for now, and I can see that it has generated a file by name example.obj. So if I again open the folder, I should be able to show you that this was a file and it was given to a compiler, and that generated example.obj. Now this example.obj is not an executable file, so it won't run. So we have reached here, and now what we need to do is we need to submit our example.obj to a linker, and that will generate a binary file for us. So again, we'll submit it to a linker. So in here we have link exe file, and we can submit it to link exe, and we can give the obj file to it as an input. And once I hit enter, let's see what happens. So what I get now is an exe file generated. So we have got an exe file. If I open the folder, I should be able to show the exe file to you. So we have got the exe file, and now what we'll do is I'll run the exe file, and we get hello world. So our first C++ program is running. So moving ahead, I'll be writing the same program in a Visual Studio environment. I'll show you like how we can create a new project in a Visual Studio environment, and we'll write there our first C++ program.